Sharath, we've had certain discussions about we only predominantly discuss about hierarchical and non-hierarchical, and within non-hierarchical specifically k-means clustering. So my question is, there are other clustering algorithms, for instance dbScan, which is gaining a lot of popularity. So are the hyperparameters different for them, and if they are, how do you choose, and how are the values? Could you throw some light on that, Sharath?
Yes, Nitin, thank you. Yeah, so every algorithm has its own set of parameters, depending on what is the logic the algorithm is defined on. And dbScan, again, is density based. So when you say density, we are basically looking at how closely the data points are grouped together, clustered together, right? So if they are densely placed, then it becomes a cluster. So based on that logic, if you look at the implementation, what we need is the area in which you can see that densely populated data points. So to capture that, we need minimum 2 parameters, mandatory. And of course, there are other parameters also in dbScan. But dbScan is also having this disadvantage, which basically says that it is heavily rooted onto these 2 parameters. One is the radius of the circle. The other one is how many minimum samples do you expect in that particular small area, or whatever the area that you are defining. The radius by default is expected to be 0.5, you can see. It is defined as EPS. And then we also have this minimum samples, which is again considered to be 5 as the default option. So we're basically saying that within the radius of a data point, from the data point, if I take 0.5 distance, then if I do a circle, minimum there should be 5 data points within that circle to define that as a cluster, or define that as a data point which is forming your cluster, right? Cluster center, you can see. And along with these 2 parameters, whenever we speak about clustering, the most important thing that we need to look at is measuring the similarity. And that measuring the similarity happens with respect to distance calculations. And again, metric is one of the parameters that we use, which by default takes Euclidean option. And likewise, we have different algorithms, leaf size, metric parameters, etc., etc. A set of parameters that are available, which again, you can refer to the cheat sheet that is being made available for you all in the website, 360 Energy website. You can go through that cheat sheet and understand what are the various parameters that you can actually have for each of these function or algorithm that we are frequently using. So to summarize, EPS and minimum samples, that these are the 2 things that we need to look at.
Thank you, Sharath. Bharani, would you like to add something to the topic of dbScan there?
Sure, Nitin. So can I share the screen?
Yes, please.
Okay, let me share the screen so that people can relate.
Yeah, in the interim, just want to let our audience know that we have seen your questions. We'll be taking them up in the next 3. After Bharani's thing, we'll be taking up all the questions that are there, just to keep you informed. Please stay till the end of the session, and all the questions will get answered then. Yes, please go ahead, Bharani.
Yeah. So let me share my screen. Okay. So these are the 3 things which Sharath is talking about, or already spoken about. EPS is like, are you guys able to see my screen? The black screen with the yellow writer?
Yes, we are able to see.
Yeah. So there is p-value, which is basically distance. If you say p equal to 2, that means it is Euclidean distance. And for EPS, this is more or less like radius from one point to another. What is the distance, right? That's EPS. And minimum samples is you need, if you say minimum samples equal to 5, if you have minimum 5 points in the vicinity of a data point within the radius, then this data point for which you're, okay, let me take one step back. Each data point is supposed to be classified as a core point or not. To classify whether this is core point or not, you need to look at EPS and minimum samples. EPS is a radius. You just draw a radius. And minimum points, if you have minimum 5 points within that radius, this point would be called as a core point. In that way, you perform the exercise for all the data points. Okay, point number 1. So EPS and minimum samples obviously are the two key hyperparameters that one has to remember. Alongside that, if you ask me what is the other thing that I need to remember, p-value, because distance plays a key role in determining the number of, the kind of clusters that are going to emerge out of any clustering exercise. If you say p equal to 1, that means you'll have Manhattan distance, right? Which is also called as L1 norm. Euclidean distance is also called as L2 norm. Right? And there is one generic hyperparameter which you will find in a lot of algorithms which support parallel processing, which is number of jobs. If I say number of jobs equal to -1, you might have dual core. Dual core means there'll be 2 cores. Both the cores will be used in parallel. If you have quad core, you'll have 4 different cores and all 4 cores would be used for parallel processing. If you have octa core, that means you'll have 8 cores and all 8 cores would be used in parallel. When you say number of jobs equal to -1, this is yet another hyperparameter. And knowing these kind of hyperparameters once is sufficient, because whenever you see it next, you can proceed further with that. And yep, p-value, EPS, minimum samples, and number of jobs. And there are a bunch of other, but these are a few things that you might want to remember. And the default values of these are also equally important. Yeah.
Thank you, Bharani. So yeah, we have just about enough time to address some of the questions that has been asked. So Sharath, I'll take your inputs on this. So we have a question here. What is classical K and spherical K means? What is the difference between the two? So could you throw some light on that?
Yeah, definitely. The classical K-means is the technique that we are discussing. This is the default technique that we use. Basically, what we do is we randomly select the centers for your entire data set, depending on the number of K, and then we start measuring the distances of each and every data point from this particular center. And whichever record is closer to a specific center that we initially decide, we group these records within that cluster. We assign that record to a cluster which this data point or center represents. Whereas in spherical K-means, the logic is that we do not really worry about the magnitude here, the distance that we speak about, right? We don't worry about the magnitude. Rather, in spherical K-means, we are trying to form spherical clusters. And in order to achieve this, we try to normalize the length of all the vectors that we have to 1. That way, I really don't worry about the distance spread. We are normalizing the data, right? So we don't get different distances. We get the data normalized to 1. But what we get is the angle. And to capture this angle, we use cosine similarity based technique in the spherical K-means. So if your data is non-spherical and all that, then we use classical. But if your data is kind of forming spherical shapes, then we use spherical K-means. And when to use, again, as I mentioned, this shape does matter. The other thing is when your magnitudes are not important, not particularly important for you when you're talking about the variation. So these are the 2 cases where your spherical K-means can be used over classical or standard K-means algorithm.
Thank you. Thank you so much. We have one more question before we wrap up. So, Bharani, I'd like you to take this question. So,
Sure.
K means versus K medians. When to use
Yeah.
what? What is
Absolutely.
yeah.
So as part of data pre-processing, we have outlier treatment. When you have outliers, you need to treat those outliers. And we have the 3R technique wherein you either rectify the outlier if it's a mistake, or you remove it if it's one-off case, or you retain it. When you retain your outliers in your analysis, that is when you need to go with K medians, because you have outliers in your data set and you cannot remove them. Because of business rationale, you need to include them in your analysis. That is when you prefer K medians over K means, because median is not influenced by outliers, whereas mean is influenced by outliers.
Pretty straight answer. And